Hello, and welcome to the very first special edition of the Nameless Show. I am your humble narrator, the Madman, and today we're going to be looking at a short video posted by a gentleman named Eric Dubay, who, if you don't know who Eric Dubay is, he's pretty much the top of the flat Earth pyramid, so to speak. And let's take a quick look at his basic assertion. Gravity is just density. Well, no. That seems wrong to me, so we're going to have to take a closer look at this video. I decided to take a break from the other projects breaking down larger flat Earth videos, and when this little 5-minute gem came onto the radar, I couldn't resist. Funny little Eric Dubay story. About 3-4 months ago, I was on a bunch of different flat Earth videos, posting a comment just asking for a picture of the edge. By the way, at this point, and this is to all the flat Earth folks out there, I'll accept a picture of the edge or the dome or any aspect of, reality as it exists on flat Earth. So throughout this video, we're going to be taking the position that Earth is Earth, and there are certain realities about Earth, and one of them is that it is an oblate spheroid that's orbiting a star. Which is something that all observation and mathematics and scientific experimentation support. So, I live on Earth, and Earth is round, and I have no idea how the conditions or history or culture of the flat Earth people go. But I'm a friendly and gregarious guy, and I'm always eager to learn. So, but from the perspective of this video, we'll just be sticking to the reality that Earth is round. And so, without further ado, let's see, what else can we talk about here? Okay, we can talk about the structure of the video. You'll notice that the music is kind of ambient and ominous, uses a lot of discordant notes, and that's to force the viewer to concentrate on the images and the words. So what we have here is just a balloon floating roughly in equilibrium with the air. It's got some helium in it and some normal air, and as a result, the force of gravity, which was equal to the mass of the balloon plus the mass of the gases inside the balloon, forced downward, the fact that the helium in the balloon is able to overcome that rather slight gravitational attraction, and the balloon actually floats on an ocean of air because of differences in density between helium and normal air. We'll take a look at the periodic table and go into a full description of why helium floats on air. But first, let's take a look at this little statement right here. Gravity holds people, buildings, and huge oceans stuck to the Earth's surface but cannot pull down this balloon. Well, one of these things are not like the other. People, buildings, and huge oceans weigh vastly more than the balloon. And that's why it's relatively easy to overcome the slight gravitational attraction of the mass of the balloon, and not so easy to stop yourself from falling if you step off of a surface or whatever. Now let's talk about some of the properties of matter. Mass is something that is perceived by us as weight on Earth, but it's not the same thing, and volume is simply the size of an object in 3 dimensions. But there's another property called density that combines the properties of mass and volume. And the property of density is something that we use to describe the mass of an object divided by its volume. Okay, and as you can see, these densities are commonly expressed in either grams per milliliter, grams per cubic centimeter. If it's a gas, like the atmosphere, it might be grams per liter, because it's more convenient to weigh that way because gases weigh so little. And the density of water is 1 gram per milliliter. And water is kind of the gold standard for judging how dense something is. So let's get back to the video. We already know what's happening here. It's no great mystery. Helium is lighter than air. There's enough helium in that balloon to overcome the small gravitational attraction between the balloon and Earth. And thus you have a sort of equilibrium where the balloon just floats on air. Now, where is gravity now? That sneaky gravity. Now, in order to find out why that rat bastard gravity has deserted us, we are going to have to look at the periodic table of elements, which we'll do here in just a second. Now, periodic table. Similar elements are grouped together by color. From the top left to the bottom right, elements go from lighter to heavier. Okay? Now, in the early days of aviation, because there was science, even back then, scientists had identified that hydrogen was the lightest element, that it would easily float on air, and so what they tried to do was put it into balloons and rigid airships. The problem with hydrogen is that it's highly reactive, so although it was ideal in that it was able to float easily on regular air, if there was a fire or a spark in one of these craft, what would usually happen is that it would explode. And you can Google Hindenburg disaster for an old movie, a bit of old movie footage that shows what happens when when one of these things catches fire. So at any rate, although hydrogen worked great as a flotation device, it was dangerous. So scientists then turned to the second lightest element, which is helium, right over there on the top right of this chart. Now, helium is part of a group of elements called the noble gases. And the reason why they're called noble gases is that they don't react readily with other elements under normal conditions. They remain distinct. So helium is also lighter than air, so it's a good flotation device, but it also won't explode if there's a fire. In fact, if you try to start a fire in a helium balloon, you'll find that you cannot do it. So anyway, these noble gases do not react with other elements, yet helium is quite a bit lighter than the elements in air. If you'll look just to the left of helium, you'll see three elements, C, N, and O. That's carbon, nitrogen, and oxygen. Oxygen, obviously, is present in air. We need it to breathe, so there's oxygen in air, and it has an atomic weight of 16. Helium only has an atomic weight of 4, so oxygen is 4 times heavier than helium. Nitrogen, right next to oxygen, is also in our atmosphere, and it has an atomic weight of 14, so it's 3.5 times heavier than helium. You also have carbon compounds like carbon monoxide and carbon dioxide. Carbon monoxide is carbon, weight of 12, plus oxygen, weight of 16. That's 28, which is 7 times heavier than helium. And then finally, if it's carbon dioxide, it would be a total weight of 44, which would be 11 times heavier than helium. So you can see that when gravity is trying to pull down a balloon that only weighs, say, 5 grams, plus the helium that's inside of it, the helium is so much lighter than all the elements around it, that the balloon, it's able to overcome that slight gravitational attraction of 5 grams plus the weight of the gas, and actually cause the balloon to float. So this is science. It's not a magic trick, and it's easily explainable. And if you've never looked at the periodic table, I highly recommend it. Chemistry is one of the most useful bits of scientific knowledge that you can have. Of course, that's only if you don't stop to consider that, you know, all science is based on the round Earth, so it could all be a lie. Okay, so where is gravity now? Well, gravity's still there, but the helium is able to overcome the force of gravity. Same with this group of balloons. Why isn't gravity pulling a group of helium balloons down? Well, same reason it didn't pull a single helium balloon down. Now, what would happen if these guys were outside is that eventually they would rise to a sufficient height where the pressure in the air around the balloons would have dropped enough that the balloons would pop, and that's eventually going to happen. But as to why gravity isn't pulling it down, it's trying, but the helium is preventing it. But again, look at the comparisons we're making here. Balloons that weigh almost nothing compared to a human or a ship or a mountain or the ocean. And the best evidence for why this hypothesis that gravity is just density is nonsense is coming right up. Now, this is a great demonstration of gravity itself. You will notice that despite the fact that these two objects have different masses, they have probably the same density because they're made out of the same stuff. Now, the demonstration is a bit misleading because when the slinky compresses, it's going to cause a reaction. But you will notice that while these objects are falling through space, and they're extended, and the top is falling toward the bottom. They're both falling at the same rate. And so that means that gravity has nothing to do with the mass of an object in that it accelerates everything toward the Earth at the same rate. However, these two objects have different masses, so when they hit the Earth, the force of the impact is different. The speed is the same, but the force is different because the weight is different, or I should say the mass is different. It works the same way everywhere. Falling at the same rate, the ground. Okay, so gravity does not accelerate objects toward the center of the Earth based on the property of mass. We know that from this demonstration, and thank you, Mr. Dubay, for including it. By the way, that's not Mr. Dubay. He prefers not to appear in his videos, so I really have no idea who this is. So this demonstration of gravity, again, you've got your slinkies. They're made of the same material, so the density should be roughly the same. Okay, now what we're going to do here is clumsily try to go back and look at not when these things hit the water, because that's just a simple matter of density. The ball on the right is filled with air, and so it is not heavier than the water it's trying to push out of the way, so it floats. Up, and bam, right there. Notice how the two objects fall through space at the same speed. Bam. So now we know that the gravity is not acting on the property of density, because this object on the right is less dense than the object on the left. How do we know that? When they hit the water, the object on the left, which is like a pool ball or something inside a balloon with a little bit of air in it, is still denser than the water around it, so it sinks. The object on the right is a ball filled with air. It is not more dense than the water, so it doesn't sink, it floats. But they both fall through space at the same rate, and Mr. Dubay, you have just elegantly disproved your own hypothesis. So we thank you for including real science in your videos. It makes them self-debunking. They're awesome in that respect. As actual facts, not so much. Okay, brick versus sponge. So the brick on the right is more dense than the water. It falls to the bottom of the tank, most likely with a pretty decent clunk, and that's why that guy flinched. The sponge on the left is less dense, so even though it hits the water at the same time as the brick, again proving that gravity does not act on the property of density, it doesn't sink right away. Instead, it starts to soak up the water. And this is just basically a bunch of different household objects, and all you can really tell from this little demonstration is which objects are less dense than water and which objects are more dense than water. The objects that are less dense is everything floating. The objects that are more dense than water is everything on the bottom of the tank. So although this is a great demonstration of the density of different household objects, it is absolutely meaningless as a demonstration of gravity. The little ball on the left may be problematic for some. Yeah, the ball is made out of plastic, and the plastic is probably pretty light. But because it's full of holes, there's no place for air to gather. So you have gravity acting on just the mass of the ball, the density of the ball, which is clearly greater than water. So although it might be made out of a similar material as balls that are floating, the difference is they have air stuffed inside of them that can't escape. Okay, so real science. A cubic centimeter of water is 1 gram. Now this is a density comparison. You have wood, water, and concrete. So wood should float in water. All right, so maybe, I don't know the entire purpose. Maybe this is supposed to be demonstrating to us that the wood isn't floating. But here's what I would say. Either it's not wood, or more likely it's pressure-treated wood, which is more dense than water. If you don't know what pressure-treated wood is, or if you've never handled regular wood versus pressure-treated wood just has a bunch of chemicals forced into it to basically retard water and make the thing kind of unpalatable to bugs. It really hardens the wood and makes it more dense is what it does. So pressure-treated wood is much heavier, and that's why it would sink versus regular wood. Or it could be regular wood that's glued to the bottom. At any rate, the scientists just wanted to protect the bottom of the tank. This is just showing how objects of different density to what extent they should sink into water. So if it's half as dense as water, it should sink about halfway. If it's 90% as dense, that would be 0.9 grams versus 1 gram. Then it should sink 90% of the way. All right? So this is all real science, and again, there's nothing wrong with it in particular. It just has nothing to do with gravity, really. So, like, I kind of don't know what the point of the video is at this point. I swear to you, I don't. There is no level on which this theory works. Yes, buoyancy, good, good. So the way this video is structured is the music draws you in. The little images force you to focus, or it forces you to focus on the words, and then you connect the incorrect assumption with the real science. So hot air balloons, how do they work? Well, density is also affected by temperature. So if you heat up regular air, it makes the molecules and atoms in the air want to be farther apart from one another, so the density decreases. So as you heat up the air, the water inside the air inside the balloon becomes much less dense than the air outside the balloon, and so even though it's regular air, the temperature difference makes the balloon float. And that's how hot air balloons work. But they have their own dangers. Obviously, you can set the balloon on fire, or your flame can go out, and you'll have no way to keep your altitude. So, density causes objects to fall, not gravity. Nope. You are incorrect, sir, and your own video has proved it, and we thank you. We thank you for including real science in your videos. Because, like I said, it makes them just so easy to disprove. So easy. Okay, so this is a cool little demonstration, and again, we'll be sticking with the concept here that the only thing that seems to violate, quote unquote, the law of gravity are very small objects. So you'll notice you have a die, a kernel of popcorn, a cherry tomato, some beads, a soda cap, a ping pong ball. These are all very small, very light objects. And as I've said before, that's the only way you're going to be able to overcome the force of gravity due to differences in density of substances. It's not that gravity's not there, it's just that in certain special circumstances, you can overcome that force. Which, again, not focused on density. So before we look at the following footage, I can only say I use data and historical records from my planet, Earth, and before I hear, howls of fakery and trickeration, if it is fake, then it's not good for proving anything about the shape of Earth one way or another. So it's no good for proving it's round. It's also no good for proving it's flat. And let's take a look at the perfect experiment to demonstrate that gravity.
In my left hand, I have a feather. In my right hand, a hammer.
That gravity is not affected by the property of density. So here we are on Earth's moon. Earth's moon has no atmosphere, so there's no air to get in the way of either of these objects falling straight down toward the center of the moon. The moon has its own gravity, which is weaker than Earth's gravity, so you're going to notice two things.
I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon.
Okay, so what we're going to see here is, like he said, a hammer in his right hand, a feather in his left hand, and the test is to see whether they fall at the same rate. If they fall at the same rate, well, it's clear the hammer is much more dense than the feather. Okay.
So we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time.
Okay, so, and as we see, in the absence of any kind of atmosphere, the moon's gravity does in fact pull these objects toward the center of the moon, just like it would happen on Earth, at the same rate. So gravity has nothing to do with density because the feather is much less dense than the hammer is, and without any kind of resistance from air, then that takes out that element and just goes to show that A, gravity works the same everywhere on the moon as it does on Earth, and B, that it has nothing to do with density. Now, even if this is fake, let's not forget that this is just the icing on the cake. Mr. Dubay himself has already, I don't know, included footage in his own video that shows that objects of different density fall at the same rate on Earth. So his entire hypothesis, which is all it ever was, which really, like I said, was just a prepackaged or a repackaged version of Aristotle's hypothesis, was wrong. Yeah, how about that?
Mr.
Galileo was right. Now, the interesting thing to note is that Galileo didn't discover that about gravity until the 1600s. No, sorry. Yeah. 1600s, 17th century. So for the better part of 2,000 years, people labored under the wrong assumption about gravity, that it was related to density. So that just goes to show how wrong people can be and how long they can be wrong for. But this video does not stand up in any way to any kind of even like cursory scrutiny. And I'm glad that there are dedicated civilians like me to handle this kind of popular tripe so that real scientists don't have to. They've got more important stuff to do. So gravity, just a theory. Well, so is the idea that germs, bacteria, and viruses cause disease. But just like gravity, that's also true. So at this point, the video is just playing a game of semantics, a word game with the word theory. In popular use, it means something that you think might be true. But for scientists, it means the body of work that supports an idea. Gravity is a lie. No, sir. You, Mr. Dubay, are lying. And I'm assuming this is just supposed to show how the ridiculous proposition that somebody on the opposite side of the sphere from you is, in fact, oriented differently than you. But yet, that's how it is, because gravity exerts an equal force toward the center from every direction. So, yeah, as weird as it may seem, yeah, that's the case. But you get there slowly. If you have to sail there or whatever, your orientation slowly changes as you sail across the ocean. Okay, now this is a great one. Gravity, strong enough to stick trillions of gallons of water on a sphere, but weak enough not sink a man in a kayak? I can almost see like the question mark. Okay, well, so why does that happen? Well, it's because the weight of the kayak plus the weight of the man don't equal the weight of the water that it's trying to push out of the way, so it floats. It's just like the experiment we saw in the fish tank. It's the exact same concept, and we all know that boats float, just like we all know that gravity is real. I think even the people who try to say it's not, they don't know it is. Oh, goodness. Now it's just melodrama. Go jump off a cliff. Yeah. And that just proves that you're denser than air, but not as dense as the water. Science class dismissed. Yeah, well, like I said, Aristotle was wrong about gravity being just about density or having anything to do with density like 2,400 years ago. And Mr. Dubay, you're wrong now. The science is simple, it's obvious, and your own video demonstrates that your premise is false. So, final thoughts on this video? I mean, it's a well-constructed piece of propaganda. I think it's cynically made to draw in people to be suspicious about, whatever sources of information. Okay, so this is a richly ironic portion of the video. This is what happened to Galileo when he proposed that gravity wasn't related to density and turned out to be right over 400 years ago. First he was ridiculed, then he was violently opposed, and then, unfortunately too late for Galileo, it was accepted as being self-evident. Which it is. Still no face. Oh, had to work in the old masonry fucking symbol. Sure, why not? It's the Masons. It's the Trilateral Commission. It's the Bilderberg Group. It's the Reptoids. It's the UN. It's the Illuminati. So final thoughts on this video. I mean, it has just as much validity as any flat Earth video. That is to say, none. But I hope you did enjoy watching it. And if you stuck with me this far, thank you very much. If you liked the video, please give it a like. If not, give it a thumbs down. If you'd like to support this effort, please consider subscribing. And until the next time we talk, treat yourself and each other well, and have a great day. Peace out.